chapter 3 already, but we still stuck at chapter 1. So we need to go a bit faster. So just a reminder, how we set the question. We're referring to the learning outcome. Learning outcome number 1, number 2 will be in your test 1. So your test 1, question 1 will be need to use the equilibrium equation. Number 2, question 2, we will cover up to dry friction. So we need to go a bit fast. We now in week 3, our test will be in week 7. So we still have 4 weeks to cover a few chapters. Okay. All right. So we're now still stuck at here. Okay. So there are 1, 2, 3, 4, 5, 6 chapters to go. Okay. So you already have a honeymoon for 2 weeks. So we're going to, I assume you already know how to do vector, how to do splitting of vector and so on. Okay, I already upload two appendix in the Canvas, if you're aware. 2 new document inside Canvas. So there's additional 2 appendix document in the Canvas, Appendix A and Appendix B, if not mistaken. So go and download and read lah. Okay, so we have completed what is parallelogram law previously. Parallelogram law means when you see 2 vector or 2 forces, you draw a parallelogram and then you split them into respective axis, right? And you convert parallelogram into triangular cosine law. So that is previously what we did. So we already assume you already know. Okay, so based on this diagram, we have vector, we have scalar notation and vector notation. So scalar means magnitude. We try to find magnitude. So parallelogram law, if you have 1 forces, we can split into 2 components. This is a resultant. We can split into 2 components. One is in X, one is in Y. Of course, this one is in right angle. Previous class, we don't have a right angle vector because in parallelogram, you only have parallel axis. So F equal to Fx and Fy. So this one you should know because when we move this vector combined with the head here, we put here, pull to here. So from start, connect with vector, you reach the end point. So resultant is from start to end point, the blue color, start to end. So you write F on the left-hand side of the equation. Then right-hand side of the equation is the component that combine from the starting point to the end point. Okay, so this is how we do. All right. Now, if we look at this diagram, if we have a X and Y axis, that we have a in Cartesian plane, we know that X and Y, they are in 90 degree, in 90 degree. So if you are not aware, then make sure you remind yourself that we are now looking at X and Y axis, which is both 90 degree. So when you have 90 degree, you can use the trigonometry equation, which is sine, tan, and cos. Because why? We have 90 degree over here. Okay. Then you need to find the angle. So how do you split this blue color arrow, which is your resultant, into x-axis? With this, you use the cos law. So cos theta equal to the side divided by the hypotenuse. Who not familiar with the trigonometry? Who not familiar with the trigonometry? Tangent, cos, and sine. Okay. So if you're not familiar, go and go to the Canvas, download or open the Appendix A or Appendix B. There's explanation there. So when you move the equation, let's say we take cos theta with this C divided by A. Right? So if we copy this diagram directly into cos equation, cos theta equal what? Fx divided by f. So when you move this equation, your fx equal to f cos theta. Make sense? All right. So if you understand this one, you can also do tangent or sine. But most of the time, we will use either one of these. It depends on condition. Huh? So fx equal to f cos theta, fy equal to sine theta. Okay, any question? No, huh? Okay. Sometimes the question help you, it will straight away give you in degree. Sometimes the question will give you slope with this triangular. Okay, this triangular. Here is C, B, and A. So don't panic if you see this one. If you just apply what you understand in sine, cos, sine, tangent, cos. How you do? You just place an angle here. Okay. So when you place an angle here, which is this angle, or this theta equal to this theta, right? It's a Z one. Okay, this theta equal to this theta. So when you do, you splitting x and y also same. So what is fx? Fx is cos, right? Cos this one divided by hypotenuse. So what is cos? Cos is A and C. Okay. So you need to be smart enough to process the data. It's not always capital C or capital A. You need to understand the concept. What is cos, what is sine. So one approach is using the proportional length. Just now I mentioned, you remember as a theta, but some of you might learn using the proportional length. What does it mean? As you can see on the screen here, fx means you move this one to here. You pull this one, fx to here. So fx, this line, will equal to A. This line will equal to this one. Okay. Then this f will equal to C. So you write fx equal to A, divide f equal to C. Then it depends which one is missing. Usually A, B, C will be given. Then you're finding the missing parameter. Easy, right? Any question? No, Again, I go very fast today. I go very fast. If you don't understand, raise your hand. Let me know. So the rest is just mathematics. You just move around whatever is necessary. Yeah. Same with B and C, B and Y. So it depends what you want to find, fx or fy. Okay. So the fraction here, A divided by C or B divided by C, is the same if you understand sine, cos, tangent, cosine relationship by putting angle over here equal to angle over here. Okay. When you see this kind of question, don't go and convert into cos and sine. Don't use, let's say, AC. Don't convert to cos theta because of accuracy. Okay. If the question gives you this triangular, please use the fraction rules or fraction or the proportional rules. If the question gives you this one, you go and write cos theta. I put question mark. Where is theta? There's no theta in the question. So there are two ways of solving question. One question, you will see theta. One type of question, you see theta. If you see theta, you can use tangent, sine, and cos, whatever you feel comfortable. Usually, you see this one is linked with these three, tangent, cos, and sine. It depends on what is missing. Okay. Second one, if you see this kind of diagram with median with a small triangular, please use proportional or proportional equation, like what you see on the screen here. Okay. Now I want to highlight this one. In my slide, I purposely put this one in different color. When you do proportional, remember to look back your diagram. In general, all the position to the right will be positive. All the direction going up is positive. If you see the vector go opposite of your general axis, please write negative for your answer. For example, this one. Okay, you can pull the negative out. Negative, it means Fy is going down. Fy going down. If you forget the negative, it means your answer flip up. Then the resultant will go this way. So be careful on the positive negative sign for static and dynamic. Right? So you're taking statics. It's a good start, and start with a good habit when you answer question. Statics question will link with other module also. So if you have all these careless mistakes, then it's not good for your test or final exam in other module also. You are dealing with vector. Force is a vector. Vector have magnitude and direction. So direction, how we link with direction? Again, positive in general. To the right, positive, going up, positive. It depends on what you draw on your diagram. Okay. So this one you read. Okay. So this statement, please take note. It's important to keep in mind that this positive and negative scalar notation is in your calculation only. In your diagram, there's no negative sign there. Okay. So what you calculate in your calculation solution, you can use negative. But in your diagram, there is no Fy negative. If you put negative, means this arrow flip up. So in your diagram, all is positive and showing the correct direction. If you see negative here, means that this arrow flip up already. Yeah, so this is a good habit. Please practice. In your free body diagram or your diagram, no negative value inside there, because diagram is showing direction and magnitude. Magnitude always positive. Direction is only one direction, either go up, go down, or left or right. Okay. Okay. Next, sometimes you need to solve in scalar notation. Sometimes the question will force you to use Cartesian vector notation. What's the difference? When you see Cartesian vector notation, you need, in your answer, we're expecting you're using I, J, and K. All right? Who don't understand what do I mean by I, J, and K? I write something on whiteboard. So X axis, Y axis, Z axis. In your secondary school, you learn about unit vector. If you see I, it means towards X direction. If you see K, it means J, it means Y direction. If you see K, it means Z direction. On the slide here, I just show you two-dimensional first, then we go to three-dimensional. Okay. So on the case here is what same like what I write on the whiteboard. So this blue color is the resultant. Sometimes the question give you fx and fy, you need to find the resultant. This is what we did for the previous lecture. Today, you are seeing resultant, you need to split into x and y. fx, xy. This is called component. Component of the resultant. Then you will see I and j, both bolted because they are vector. They are vector. I and j, they are called unit vector. They are called unit vector. Okay. Vector have what? Vector have two things, magnitude and direction. The word unit here, it means the magnitude is 1. The magnitude of that vector is 1. Direction for I will be along x-axis. Same with j. Unit vector j means the magnitude is 1 and direction is y direction. Okay, so you have I, j, and k. On the slide here, you only see 2 members because this is 2-dimensional diagram. Okay, so the rest is there. Okay, so magnitude always positive, that's what you know. So you can express f and the resultant f here into fx, fy. This fx is a scalar vector, which is a magnitude, right? So fy also is a magnitude. Just now, when you split this one, f cos theta, you get this one. That is scalar, means you are finding magnitude, not vector. So how do you convert this one into vector? F equal to fx plus fxi plus fyj. I purposely highlight it with a different color. If you see light blue, it means vector. If you see green color, it means scalar. Scalar means magnitude only. Okay, so try to understand this diagram. When you have a resultant, you split into Cartesian notation, Cartesian vector notation. You need to write in this form. F equal to fxi plus fyj. Yeah. So there are 2 ways of presentation in your answer. One is scalar, one is vector. Or you see Cartesian vector. This one, you will see tangent sine cos relationship. For example, f equal to fx equal to f cos theta, for example. This is magnitude. Okay, this is resultant is vector. Vector have magnitude and direction. So this is scalar, magnitude. Direction, you already know. What is the direction? X-axis. Go this way, positive. Right? Same with the y. Okay, when the question C force you to use Cartesian vector analysis, you are seeing the first step always you write fxi plus fyj plus fzk. This is scalar, this is scalar, this is scalar. Okay. And in your mathematics class, how you find magnitude of this Cartesian vector? You remember? How to find? You remember square this one plus square this one, square root? You the same. So this one is just to tell you that this is vector, this is scalar plus vector, but scalar vector. Okay. Okay, this side, magnitude of your f will be square root of fx square plus fy square plus fz square, for example. Okay, so you have 2D, you have 2D. I and j, they are 90 degree, so you can use triangular. So theta is over here. How you find angle? You use tangent. Theta equal to fy, fx. This is fy, this is fx, right? So to find theta, theta equal to tangent inverse fy, fx. Any question? Okay, nah? So there are different solution. Again, sometimes you need to answer in scalar, sometimes you need to answer in Cartesian vector analysis. So Cartesian, standard one. Cartesian, you write this formula, find your fx, fy, fz, then you find magnitude, square root, and so on. 3D one, I will tell you how to do later. Okay. You look into tangent graph, do you see negative? No, man. No, man. Your tangent graph like that, right? Like that. Something like that. You go and see. Right? It will be infinity and then 0, then go to infinity. Something like that. Okay. But this is 2D. 3D is the standard method. So let's say just now all the while you see only two forces. In engineering application, of course, you will be dealing with more than two forces. So apply what you learn. You just add one more forces there inside equation. Coplanar, what does it mean, coplanar? It means in the same plane. We are working at the same plane. Plane means a piece of paper. All the force is acting on this piece of paper surface. Okay. So let's say you have three forces acting on the origin of this axis, F1, F2, F3. How to find resultant? Resultant is to combine all these forces together. Resultant equal to F1 plus F2 plus F3. Then it depends on whether you are using scalar method or vector method. Okay. Okay. So from today onwards, beside parallelogram law and triangular rules, which is cosine rules, parallelogram law and triangular rules, that one only apply for two forces only. If we have more than two forces, please split all the component into x-axis and y-axis. Actually, this is more easier way in solving question. So you split F1 into Fx and Fy. How you write notation is important. Don't all the forces you write F, X, and Fy. Then you have three. You have if you without the sub 1 or sub 2 or sub 3, you have a few pairs of forces in the same direction. So remember, your notation is important. If you're referring to the first forces, F1, please write F1 in x-axis, you add another x behind the 1. For example, Fx1, x-axis will be F sub 1x. Please write in this form. Okay. Then same with the y, F1y, repeat for the F2 and F3. Yeah. So when you split, you just, if you don't know, you just draw a rectangular. Draw a rectangular, then draw a straight line for x, draw a straight line for y. That is your direction. Careless mistakes always, sometimes when you draw these two, the y direction, you will mix them together in one and you'll forget either of these in your calculation. So when you split them in your diagram, please draw a little bit, distant a little bit from the y-axis, like what you see on the screen here, so that you don't make careless mistakes. There are two forces in y-axis, right? And one going down. Okay. Next question is from this diagram. How many positive forces, a positive vector, a positive scalar, a positive vector, I should say. How many positive vector? 2 for x, 2 for y, so total 4 positive parameter. So this is negative, this is negative. So we have 4 positive, 2 negative value in your calculation. And again, you don't see negative value in the diagram. You only see negative in your calculation. Don't go and write negative here. You write negative f2x, it means this one flip to another side. Okay. All right, so I'll just give you a very quick one. There are two of solution. On the left is scalar, on the right is Cartesian. On the right, if you use scalar notation solution, resultant split into resultant in x means you split the question by solving x and y direction. Okay, means if you see a lot of forces, don't panic. First step is to split them into x and y direction. Each one of it have 2 directions. Then solve your question, you write, this one is important. Write positive arrow, you write positive arrow pointing to the positive direction. Positive to the positive direction. Then you write bracket fr sub x, means in x direction, or the resultant in x direction. Then group all the x direction. For example, x1 positive, x2 x is negative, x3 positive. Okay, so positive, negative, positive. Same with y, right? In your answer, positive, what is positive direction? Go up. Bracket fry, then group all the y in one solution. Fy positive, go up. F2 positive also, but F3y is negative, go down, negative. So for static, write the general equation first. Don't so quick to substitute value inside there. Write equation first, then tell me what is so and so. So just highlight this one. Generally, for x is this direction, for y is going up. Generally, when you come to chapter 3, this one you need to do a little bit of modification. But for chapter 1, we assume this one first.
Positive and arrow pointing this direction.
Okay. So this is general equation. So when you substitute value later, you come up with a negative. What does it mean? It means the real direction is what is opposite from what you expected. This is your expectation, your hypothesis. So I will highly recommend, don't go and change the direction. In your calculation, if you get negative, stay negative. If you're expert, then never mind lah. You can go and flip lah. But for beginning, stay negative in calculation. Then when you do calculation, also carry the negative value there. Then at the end, you get negative again. Then you just conclude what is the direction. Don't in the middle go and change positive and negative. Don't confuse yourself. If you get negative, stay negative until you get the end. Still negative, then you know that okay. If you get negative, then is opposite. You see this one in example. You see this one in example. Same Cartesian plane or Cartesian vector notation solution. You need to include I, J, and K. This one is 2D dimension. So your solution will look like this. So first, standard already. First, you write F1 equal F1xi plus F1yj. Write this one. Okay. In the test, if you forget to write, because vector is how you write is different. So if you forget to write this one, I also give you correct lah. As long as your answer got I, J inside there. Okay. So it's just that keep on reminding. Vector is there is a way of writing, but in your test or final exam, I think I don't go and pay attention to the curly or arrow in your answer. As long as there is I, J, or K in your answer, then it's fine. You just said don't confuse yourself lah when you write. Okay. So what about F2? Are you able? Okay, F2. F2 is here. You split into Y and X again. So as you can see, F2X negative already. Why? F2 go to the left-hand side. So in the diagram, there's no negative, but in your Cartesian vector notation or scalar notation, same. For F2X is negative because it's going opposite of the positive direction. So F2Y positive, J. You should able to write F3 equation, right? So F3 equal to what? Positive F3I, then negative F3Y. Now, then take the J. Remember I and J, if the question force you to use Cartesian vector notation. Yeah. So again, don't confuse with the left-hand side and right-hand side. If the question asks you to use Cartesian vector, you go and use this way, 0 marks. Mean you don't understand the question. So if the question asks you to use Cartesian vector, we're expecting you to use IJ, unit vector IJ and K in your solution. Then for Cartesian vector, write F1, F2, F3, you write this one. What is the resultant vector? Resultant vector equal to all the sum of all the forces. F1, F2, F3. If they have F4, you write F4 here. If F5, you write F5 here. Again, if plus, no negative because it's the sum of all forces. Even the arrow is pointing at all the direction. But in your general equation, it's a sum of all forces. Okay, then the next steps. You pull all the expansion here, component here inside this equation. I will highly recommend you use bracket in your answer. For example, F1, bracket here, plus bracket this one, plus bracket this one. Because we are now, the one that you see here is more advanced user. So for your case, to prevent you from careless mistakes, positive, negative, you mix up already, please use bracket for F1, F2, F3. Then only you expand the answer. Yeah. Then for Cartesian vector notation solution, what you do? You group all the I together, you group all the J together, and you group K together if you have K. Your next steps will be like this. Standard one, standard. These are all the standard steps. If you write this one, got marks already. This is without substitution of value. Okay, so you write F1, F2, F3. What are the IJ component? Then you write FR equal to F1 plus F2, F3. Then you substitute this equation inside here. Then you group them accordingly. If it's I, then you bracket, group them together, plus, then you group J together. Careless mistakes, always a positive, negative sign. Some of you, there's a negative here. When you export your answer to the next steps, you will put positive here. Just pay attention. Always check your answer. Okay. Then this is your FR resultant in X, resultant in Y. Okay. So this is resultant is all the scalar notation. FRY also same. Any question for these slides? Able to answer, right? Able to understand, right? Okay. Okay. So this is just summarize the final drawing that you should put in your answer. Once you do your calculation, so there are two diagrams every time you see chapter 1 question or for the rest of the semester. When you see the question like this, the next diagram we expect is this diagram. Means you copy the same but split them into f and y. After you solve, you get the resultant already. You need to draw another diagram like this. Yeah, means you combine. After you substitute value inside here, you get your frx, fry. There's two and second diagram you need to draw, and don't shift your reference point. This example we start at 0. In chapter 2, chapter 3, we're going to move something, then something happen. At this moment, everything is simplified. Doesn't move. Okay, so yeah. No, just need to show me the direction and arrow. I will go. I won't go and measure the length of that one. So that is the concept lah. Okay. Can okay. So just a recap. So there are two types of solution. One is scalar notation. One is Cartesian notation. Solution two types. Usually this I and J, when you come to chapter 2, chapter 3, you will see three-dimensional one. You need to use the operation of dot vector and cross vector. This one usually is two-dimensional question. Okay. So there are two diagrams you need to draw for this kind of most of the time. First, you copy the axis and all the force, and then you split into this one, right? So when this one, if you draw solid line, also correct. Just label this one as F1, the blue color one, F1. Then apply for the rest. Okay. So again, resultant have its magnitude. This is vector. Vector have magnitude. So you do this equation, square the x, square the y, square root. Since this is a two-dimensional and is on x and y, it's a right-angled triangular here. You're able to find the tangent, the theta. Okay. We will use angle theta by trigonometry. Tangent. Tangent. Okay. If you have x and y axis, remind yourself there is one good friend here. C squared equal to A squared plus B squared to find the magnitude of that particular vector. This also can be your good friend. Okay. So this is tangent y divided by x. Tangent equal to what? This is your eyes. Tangent equal to what you see and the side. This one no issue. What happens if the force put here or put here? Some of you confused. Or some even put here. You confused with the theta already. Theta, you must, once you get, let's say, 45 degrees, you must tell from where. These are from where? From horizontal axis. Or you just put the theta inside your diagram. Application is what you see here. In civil, you will see cable pull from one pole. 4 cable pull in different direction. Okay, so this is important when you study structures. You need to know how deep you need to put in the piling, or you need to know how many screw you need to screw at the bottom. Okay, this is just an introduction. That's for your things. Okay. So just illustrate lah, real life application. All right. So you need to find the resultant that pull or push the pole, the object. Okay, let's apply what you learned. Determine X and Y component of F1 and F2 acting on a boom. Express each force as Cartesian vector. This question forces you to use Cartesian vector method. Okay, and you are given the two presentation, like what I say. You are seeing degree and you're seeing gradient. For F2, there's a theta here lah. So if you see this one better, you use the proportional method, although there's an angle here. Okay. So in general, what you do first, copy the question, focus on the forces. You don't need to copy this boom. Focus on forces. How many forces? Two forces. Next step, split all the force or vector into respective axes. Here you have x and y axis. So first you copy this diagram. Second, you split F2 into x and y direction, F1 into x and y direction. Once you split, then you find the resultant. You sum all the forces in x, you sum all the forces in y. And then you find angle. Okay. So try to observe the SOP lah. We will keep repeating the same method. Numbers will change. Okay. So in this case, we show you the slow method. As you progress in chapter 2, chapter 3, you rarely use parallelogram unless you don't have a right angle cases. Huh? Okay. So parallelogram law, also same lah. Also same lah. So this one is a right angle parallelogram. So you split into x and y. Who don't understand how to get 200 cos 30? Who don't understand? You understand why this f1y equal to this one? Who don't understand? Same with x, huh? Then you do the same for second one, huh? So I just need to highlight for f1x. Please write carefully, huh? F sub 1x equal to negative. Again, in diagram, there is no negative value. Negative value only in your calculation. Okay. So if you apply the calculator, you press calculator, sin 30 is 0.5. So multiply half. So get 100 lah, minus half. Apply for the same for y. Okay. In the test, you need to write the working. In my slide, I'll just skip the x. So this is just to tell you that the real direction for x is this direction. Yeah. So if you get fx1x negative 100, you look in your diagram. If it's pointing to the left, then correct lah. Okay. Means correct. If you confuse this one, just remain negative. Just remain negative. Okay. Do the same for y. Okay. So you get positive means it agree with your assumption. Go up positive. Okay. So write in Cartesian notation. Cartesian always come with I and J. You say, what happens if I forget to put the curly bracket? I still give you correct answer. As long as I see something I plus something J with the correct value X and Y. Okay, this is important. Don't go after you find value, don't substitute directly here. Please give me general equation first, then the next line only you substitute. If not, I will circle what suddenly you get value, suddenly one value there. Don't expect I understand what you write. Just assume I'm a new student. When I read your answer, I know what you are saying. Okay. Okay. So you substitute lah. So this is the vector for F1. Apply for same for F2. Repeat the same method for F2. Who don't understand how to do F2? Who don't know how to do? Same. So same, you apply the same. This one, you split into X and Y. Split into X and Y, but using the gradient. Okay. So you see, if you split this one into X and Y, we're expecting you write something like this. For Y, F2Y, you write 260 bracket 5 divided by 13. Again, if you don't know, you just shift the angle theta over here, this small triangular. Y is this direction, Y is here. You have this one, you have theta, so it's under sine. What is sine in this small triangular? 5 and 13. Can I? Cannot. Can I? Okay. So I give you the answer for example number 8. You do the same. If you don't understand this one, just ignore this one. It just tell you you get positive means it's agree with what you draw. Okay. Okay, you get negative, it means it's go down. So just highlight here, don't confuse. So right in the Cartesian plane, Cartesian notation, F2y equal what? F2y equal positive or negative I. How you write Cartesian answer for F2? F2 equal I plus J. So what you put in front? What is F2x? Yeah, you write lah. F2x, F2y. Then the next one, right? You substitute value. So what is the value for I? What is that? Positive, negative? Positive what? 100. For Y? Negative 100. Tidy up your equation. 100I, negative 100J. Remember the unit. The curly in the equation is just to tidy up the unit. Without the curly, you should write F2I Newton, F2Y Newton. If you write F2xi minus F2yj without the Newton, 50% discount for the full marks. For example, this one 2 marks, you only score 1 marks for the answer without the unit. Okay. It's not 100, it's 240. There is a typo error here. Typo error on my slide. Okay, typo error on my slides. If this question come out in your assignment, you accidentally copy this one, there's a minus mark there. Again, in my slides, there are some typo error. Don't copy into your assignment. Okay. Example 9. Determine the magnitude and direction of the resultant force. Now, this one doesn't force you to do in Cartesian. So you can use scalar notation. So still the same method. Still the same method. First step, what? Copy the diagram. Second, split all the forces into X and Y. Third steps, group all the force Fr equal to F1 plus F2. Then split the forces into X-axis and Y-axis. Then use angle to solve for the question. Okay. There are two solutions. I give you the first solution first. You use scalar notation. You use parallelogram law. You convert the above diagram into bottom diagram. Observe the method. Don't follow, don't copy the values. It will change in the test. Just see how we solve. F1 split into X and Y. Okay, into X and Y. You should be able to find value here, right? What is F1X value? In this question, what is F1 equal to 600 Newton? What is F1X, F2, F1Y? Some of you, you come here already, you confused already. F1X is what? Cos or sine? F1X, is it cos or sine? Huh? Okay, it's a cos. So 600 cos 30 Newton. Remember unit. 600 for Y, 600 sine 30 Newton. Same with F2. F2, you are given 45. But still, you need to use the correct, the value is the same, but if you write the wrong sign and cos, you still get the wrong answer in your solution, in your calculation. So for this module, even you get the correct answer, but your step is wrong, you still do not score any marks. I just circle coincident correct. So no marks. You just cast lah. It's just a lucky strike. No marks in this module. This module no lucky one. Either you do or you don't know how to do. So for F2X is what? Sine or cos? Sine or cos? Sine. Angle is here. Not here. Don't go and change the question. Angle 45 here. So your X is here. Here and hypotenuse is sine. So is F2X equal to 400 sine 45. 90, 45? Yeah. Don't go and change the question. Unless the question give you theta here, the question asks you to find theta here. Okay. So this is this one. Okay, draw your answer. There's a high note there. So you just write the same. Fx equal to what? And there's a reminder there, don't go and substitute value first, write equation first. You get one answer, positive, then it means go to the right. Uh, uh. Mm. F2,
It's going towards the left side.
F2, F2 sine 45. Yeah. Here should be negative. It should be negative. Huh? So F2 sine 45 is going to the left because your general direction is to the right is positive. Yeah. So there is a typo error here. But since this is a general, yeah, you should put negative here, right? But here also negative. There's a typo error here. Then you get this answer. Okay. Same with the y. You apply the same. Something wrong in my correct lah, correct. Right. So at the end you get the same answer. Then you have FR, FX resultant already. Don't stop here. Find the resultant of these two and the angle. Find the magnitude. So magnitude, either you square this one, square root, and the angle, it depends on what lah. So resultant positive go to the left, resultant positive go up. So you have left and right. Okay. You convert this answer, you draw another diagram, you draw FRX, FRY. If you are not sure of your answer, let's say you calculate, you're not sure 236.8 is correct, you write FRY also correct. So if the answer you write 240.2 Newton, let's say, this is wrong. If the answer is 236.8, in your calculation is 240.2, you write 240.2, I will circle this one, I put you wrong answer. So it's better you write the general equation, just for recommendation lah. Okay, theta is from, angle is here. So when you draw this one, you should be able to do that tangent equal to this one divided by this one, then inverse the tangent. Okay. Yeah. You might ask, hey, Dr. Ang, what happen if I accidentally miss out the Newton on my way of solving question? Most of the time, I still give you correct. Important is the final answer. Don't miss out the unit. Okay. Direction is the same. Okay. Answer for example 9 is 67.9. Again, 3 decimal place or 3 significant figure. If you write 68, it depends. Sometimes I'll give you correct. Sometimes I discount some marks. Okay. Because you are in the degree level, we are very concerned in accuracy. Same in the report lah. Mm. 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 Yeah, this is your final answer. Yes. Once you find this one, let's say you arrive at this theta equal to 60.9 in your calculation. In your diagram, as long as you label where is your theta, is the answer already. Means it considered complete already. Okay. So for this module, you don't need to write the final answer is what. No need. As long as you arrive at the final expected answer, then diagram, you also tell us the expected direction and angle, then okay. Or you can just bracket answer like that. Second method, just now is scalar notation. Second method, vector notation, same. Convert into x and y. Just put in ij value. Okay, ij value. Remember the bracket lah. Bracket something I plus something, then close the bracket, then Newton. Okay. There's a mistake in my calculation. What is wrong? What is wrong? Yeah. Sorry. I think a lot of mistakes. Is it correct? F1. Correct. Yeah. So if this one come out in your assignment, don't just copy the red color one. You need to put in the blue color answer. So same. What you do, you same. You draw the resultant diagram. Then group in the Cartesian, you group all the I together, you solve, group the I, J together, you solve. You might say, you might ask, hey, Dr. Can I use scalar method combined with the vector? Can. You can calculate the resultant first, then you put inside I and J. Also can. As long as if the question mention Cartesian vector notation, you give me I and J. Because why? This 400 sine 45 already you already solved in a scalar one. I also give you marks at that scalar. This one. You can write 326.8 I Newton. Oh, can. In the calculation can. Just the final answer, don't forget that unit. So because this is chapter 1, so we need to remind you actually there's a unit inside there. There's a purpose I'm showing this one. Okay. Okay, we stop here for a short break. You can try to solve this one if you want. Right? We continue 915. Okay, 915.